Every second, the universe grows larger. Galaxies drift farther apart. Space itself stretches and expands. But what is pushing it? What invisible force is making the cosmos tear itself open faster and faster? Scientists call it dark energy, and it might be the most powerful and mysterious force in existence. The expanding universe. In the early 20th century, scientists believed the universe was static, eternal, and unchanging. Even Albert Einstein added a special constant to his equations to keep it that way. Then, in the 1920s, astronomer Edwin Hubble made a shocking discovery. When he observed distant galaxies, he found that their light was stretched toward the red end of the spectrum. That meant they were moving away from us. And not just a few. All galaxies seemed to be receding from each other, as if the universe itself was expanding. This realization changed everything. The universe was not fixed. It was alive, growing, and moving. But there was an even stranger twist waiting ahead. The unexpected acceleration. If the universe began with a massive explosion, known as the Big Bang, gravity should be slowing it down over time. The expansion should be decelerating, not speeding up. So in the 1990s, two teams of astronomers decided to measure how the expansion rate was changing. They used Type Ia supernovae, massive exploding stars that always shine with the same brightness, as cosmic mile markers. By measuring how dim they appeared, scientists could calculate how far away they were, and how fast the universe was expanding at different points in time. The results were shocking. The expansion was not slowing down. It was accelerating. Something was pushing galaxies apart faster and faster. Something invisible, everywhere, and incredibly strong. That something was named dark energy. What is dark energy? No one knows exactly what dark energy is, but it appears to make up about 68% of everything in the universe. It acts as a kind of anti-gravity, a pressure that pushes rather than pulls. While dark matter binds galaxies together through gravity, dark energy drives them apart, stretching space itself. It does not emit light. It does not interact with matter. We cannot detect it directly. But we can see its effects in every distant galaxy. Space is expanding because of it. The nature of expansion. To understand dark energy, we must first understand that space is not empty. It is a fabric, a flexible, dynamic structure called space-time. When cosmologists say the universe is expanding, they do not mean galaxies are moving through space like bullets through air. It means that space itself is stretching, carrying galaxies with it. Dark energy seems to be woven into this fabric, increasing the rate of expansion as the fabric stretches. The more the universe expands, the more space there is, and therefore the more dark energy there is. That creates a feedback loop. Expansion makes more space, which increases dark energy, which speeds up expansion even more. This process is slow and gentle on human timescales, but across billions of years, it changes everything. The cosmological constant. One explanation for dark energy comes from Einstein's original equations of general relativity. He included a term called the cosmological constant, a number representing the energy density of empty space. When he later discovered that the universe was expanding, he called it his biggest blunder, but it turns out he may have been right after all. If space itself contains energy, then that energy could cause the acceleration we see today. In this view, dark energy is simply a property of the vacuum, a kind of built-in pressure that space naturally has. Even in total emptiness, quantum fields flicker with energy. Those fluctuations, multiplied by the vastness of the cosmos, could be driving the expansion. The quantum mystery. Quantum physics tells us that even a perfect vacuum is not truly empty. Tiny particles constantly appear and disappear in pairs, creating what is known as vacuum energy. If you calculate how much energy should exist in this vacuum, you get an enormous number, far greater than what we observe. In fact, the predicted value is more than 10 to the power of 100 times higher than it should be. This is known as the cosmological constant problem, one of the biggest unsolved puzzles in physics. It means either our understanding of quantum energy is wrong, or something else is balancing it perfectly to create the universe we see. The dynamic energy hypothesis. Another idea is that dark energy is not constant but changes over time. In this model, dark energy comes from a mysterious field known as quintessence, which evolves as the universe expands. Quintessence could vary in strength across space and time, explaining why cosmic acceleration might increase or decrease in different eras. If true, this would mean dark energy has its own dynamics, almost like a living force with behavior that shifts through cosmic history. So far, we have no evidence of variation, but future measurements may reveal if dark energy is static or alive. The evidence all around us. We know dark energy exists because of three independent observations. First, the light from distant supernovae shows that the universe's expansion is accelerating. Second, measurements of the cosmic microwave background, the faint glow left from the Big Bang, reveal the overall geometry of the universe. The data shows that the universe is flat, which means a large portion of its energy must come from dark energy. Third, large-scale galaxy surveys map how matter clumps across space. These patterns match what would happen if dark energy were stretching the universe. Every observation points to the same invisible force at work. The battle of forces in the grand structure of the cosmos. Two opposing forces are at play. Gravity, which pulls matter together, forms galaxies and stars. Dark energy, which pushes space apart, drives everything away. For billions of years, these forces have been in balance. Gravity slowed the expansion after the Big Bang, while dark energy worked quietly in the background. But about 5 billion years ago, dark energy began to dominate. Since then, the universe has been accelerating outward faster and faster. We are living in an era where expansion is winning. The fate of the universe. What will this mean for the future? If dark energy remains constant, the universe will keep expanding forever. Galaxies will drift farther apart until their light no longer reaches us. Over trillions of years, the night sky will grow darker. New stars will stop forming. Old stars will burn out. Eventually, the universe will enter a state called the heat death, cold, empty, and silent. But if dark energy grows stronger over time, something even stranger could happen. The Big Rip. If dark energy's strength increases, the expansion could accelerate without limit. Galaxies would be pulled apart. Then solar systems. Then planets. Then atoms themselves. Space-time would expand so violently that everything would be torn apart. This scenario is called the Big Rip, and it would mark the ultimate end of structure in the universe. The good news is that if it happens, it will not be for tens of billions of years. Humanity would be long gone. Still, it shows how powerful dark energy could become if it grows unchecked. Could dark energy change? We often think of cosmic forces as eternal, but dark energy might not be. Some models suggest it could decay over time, eventually reversing the expansion. In that case, gravity could regain control, and the universe might collapse back in on itself, a big crunch. Others propose a cyclical model, where expansion and collapse repeat endlessly. Each Big Bang gives rise to another universe. If so, dark energy could be part of a cosmic heartbeat, pulsing across infinity. For now, we simply do not know. The search for clues. To understand dark energy, scientists are conducting enormous sky surveys to map the universe in greater detail than ever before. Projects like the Dark Energy Survey, Euclid Space Telescope, and Vera Rubin Observatory are collecting data on millions of galaxies. By tracking how galaxies cluster and move, researchers hope to reveal whether dark energy is constant or changing. Each new observation brings us closer to understanding what drives the universe, and whether its expansion will last forever. How it shapes everything. Dark energy might seem distant, but it affects everything around us. Without it, galaxies would have formed differently, and the large-scale structure of the cosmos would not look the way it does. Even the age of the universe depends on dark energy. The more it pushes, the faster the universe grows, changing our estimates of how old it is. In that sense, dark energy does not just shape space. It shapes time itself. Could it be connected to consciousness? Some philosophers and scientists have wondered if dark energy is part of a deeper connection between energy, information, and awareness. If space is filled with invisible energy, could consciousness itself be part of that same fabric? There is no scientific proof of this idea, but it reflects an ancient intuition that the cosmos is alive, dynamic, and aware. While dark energy is not conscious in any known sense, it reminds us that reality is more mysterious than we can yet explain. The human perspective. It is easy to feel small when you think about forces like dark energy. Yet in a strange way, the fact that we can detect and study it shows how powerful the human mind really is. We are made of stardust, living in a universe that is mostly invisible, yet we have built tools that can measure the expansion of galaxies billions of light years away. We may not know what dark energy is, but by searching for it, we are reaching into the deepest layers of reality. That curiosity is what makes us part of the universe's story. The beauty of the unknown. Dark energy reminds us that mystery is not the opposite of knowledge. It is the source of it. The more we learn about the universe, the more we realize how much remains hidden. Every discovery, black holes, dark matter, quantum fields, opens another door to questions we never knew existed. And perhaps that is the true meaning of dark energy. Not just a force that expands the universe, but a symbol of endless exploration. The universe is not static. It is alive with possibility. Dark energy is the most powerful and least understood force in the cosmos. It drives galaxies apart, sculpts time and space, and determines the ultimate fate of everything that exists. We cannot see it, but we can feel its presence in the ever-growing distance between stars. The fact that something so vast and invisible can control the universe is both humbling and inspiring. It means that even in the emptiest parts of space, there is energy, purpose, and motion. The universe is expanding, and so is our understanding.